Okay, hello and welcome to a special HMV News webinar on the theme of optimizing heat pumps today. I'm hoping I've got this right and you can all hear me, but we're delighted to be hosting this HMV News live event with our sponsor Altecnic today. You'll be hearing from the company later in this session, both on our expert panels and in a special presentation in between them. So the overarching theme of today's event is about ensuring the best possible performance from a heat pump. It's an important topic, obviously, at the moment as the HVAC industry is being charged with helping build both the consumer demand and confidence in heat pumps as a critical technology that will be replacing existing systems such as natural gas and oil boilers over the coming decades. We're going to have a start actually today with a look at where the UK industry and government are at present, with ambitions to begin installing a minimum of 600,000 heat pump systems a year by 2028. And that'll be both across the ground and air source technologies, as well as potential for hybrids, which I'm sure we'll touch on as well. Recent estimates and official figures in the UK suggest the current capability is around a sort of tenth of this figure at the minute in terms of installation rates. But there are, of course, a range of initiatives being launched by governments and indeed by industry as well to encourage installation. So timely as it is, today's first panel is going to look at the roles of the HVAC sector and government to further build the market and try to understand a bit more with your questions about what more can be done to get the market going. And as we said, get that confidence in the systems as well. So I'm delighted to announce our first panel. They'll be taking questions both from myself, but we also couldn't do this without our audience as well. So we'll be inviting you to put your questions forward as well when you get them. Free to put them in at any time, but if you can remember to use the Q&A panel below, just because it takes me a little while to look through these, and I'll endeavour to get your questions to the panel to give us some insight on that today. But I will introduce the panel without further ado. So to start off, I'd like to say we have Altecnic's technical manager, Ed Morris. We've also got Nathan Van Gambling from the influential BetaTalk podcast, and Cordina Cretu from innovation charity Nesta, which has recently published a landmark study survey of attitudes towards heat pump use in the UK from people who've already got the systems in place. I'm also hoping we'll be joined, if not immediately, but as we go forward with Laura Bishop from the Ground Source Heat Pump Association, who I've just seen is in as well, so that works really well. Would have helped if I'd been on the ball a bit that way. So if I can welcome our panel to join us today. Thank you once again. I'm going to start, if I may, and I guess I'll begin with Cordina, if I may, not least from the with the recent report from Nesta, but about the to ask really about the recent plans to extend the boiler upgrade scheme incentive until 2028. So I thought a good place to start really to understand where we are the market was to ask the panel what incentives so far, what impact this incentive's had on industry efforts to expand heat pump use in homes and other buildings, and also to perhaps get an idea of what other initiatives or policy that the panel do believe we might be seeing an impact or is starting to push through into both the installer side and into consumers as well to get them to be interested and be able to afford heat, low carbon heat. So if I could start, so I'll bring in Cordina first, from the research to, just to, if I can ask the panel a little bit while we start of what impact they see the boiler upgrade scheme has had so far, and has it been enough so far?
I mean, we've done a lot of research in the area, not just on kind of consumer attitude, but actually we have looked at the boiler upgrade scheme more specifically. Some colleagues of mine kind of looked at the data that was published by Bays, and I think it was a year in, around 15k people applied to the scheme, and this is about kind of half of the 30,000 grants that are on offer. So a bit concerning that we've got kind of some way to go, but we did find some positive signals. So I think a few of them are around a third of households they've used the bus scheme replace their gas boiler with a heat pump, which is a bit surprising. I think we hear a lot about how it's easier to make that switch if you're on oil, LPG. So that's really great news. A lot of houses are based in a rural area in the southwest. Quite a lot of application coming from Wales. I think it's 15% more than England. So that's again really great news. And also, quite interestingly, heat pumps are not just going into the rich areas of the country. So we kind of overlaid bus applications in the UK with kind of house prices across the UK and also hourly wages across the UK. And we found that adoption of the scheme was highest in areas where the house prices and the hourly wages were kind of around the national average, which again is really interesting. But to kind of bring it back to the kind of survey results, I don't know, you might have seen it. It was quite a big kind of news story last week, but we wanted to understand as well, you know, people who have heat pumps, what do they think of them? How are they getting on? And we surveyed around 2.5k heat pump owners using the MCS database of installations, and that's across England, Scotland, and Wales, so no Northern Ireland. But we found that users are highly satisfied with their heat pumps, which wasn't surprising to us. That was good to kind of have that reassurance. But heat pump users told us that they find that heat pumps being safe, reliable, quiet sources. So it was around 70%. They said that they were fairly or very satisfied with all aspects of their heat source, except running costs, which I can talk about in more detail later. But also 2/3 of heat pump owners said that they were actually satisfied with running costs, and this compares to 59% of gas boiler owners. So this is actually slightly better results for heat pumps, which is quite interesting, and probably a reflection of recent gas prices over the past year. But just to kind of cite a few other kind of headlines from the survey, I don't want to take too much time, but for example, I'm just looking through my notes. Satisfaction with heat pumps were just as high in older properties. Again, one kind of finding they're really interested in teasing out a bit more, but we've essentially found no evidence the satisfaction varied significantly by property age. So people in Victorian homes were just as satisfied as people in mid-century properties or modern homes, and this is compared to the previous system, usually gas. But that was kind of fantastic news for us, and then really good to kind of have that concrete data supporting it. I can keep on going, but maybe I'll leave it at those sort of headlines.
We brought you in, Cordina, really to talk about the research, because I guess on top of the electrification of heat, which is the government-funded studies that have been happening, I guess we're starting to see data, the beginnings of that data that's coming in to challenge, I guess, some of those assumptions. I know we're going to talk that heat pumps in many ways, so they're new systems, they're not a new technology. So it's interesting, really. I think part of today is to look at sort of the market attitudes to that. I mean, to build on that, and I guess to move, I'll bring Laura in if I may, to start on this, particularly from the ground source side. But having talked about the attitudes of people who've got them there, I was interested from a policy side at the minute about what we've got to bring the market in, and you know, has there been encouragement at the minute from the BUS? I mean, we've seen obviously some critical studies, but also we've got the extension that I know industry's welcome. So it was to get an idea, I guess, of the policy side where you're seeing that at the moment in terms of impacts, and if there is any broader policy in a sense that you're starting to have that impact on changing perceptions.
So first of all, I just want to say that the Nesta report it's just such a refreshing change to hear that actually there's some real life people that we all in the industry know anyway who are getting on very well with their heat pumps, that we've actually got some real hard data to show people are happy with heat pumps, and in all different kinds of properties. We might talk later about, you know, hard to treat properties and heat pumps don't work in our buildings and all that myth. So it's really good to hear that. From a ground source point of view, we always knew that with the incentive being £5,000 for air source and £6,000 for ground source, it was always going to have an impact on the industry. So if anybody was looking for a replacement for the domestic RHI, this is not it. From a survey that we did just last week, actually, of our members, the vast majority of our domestic, and this is really important actually, that we have now a split in the domestic and the commercial market for ground source. If you were doing domestic ground source on the RHI, or in the years before domestic RHI came around, you will now find, we are now finding that our members are saying that that's dropped off a cliff. So the vast majority, I think probably it was about 90% of our respondents said that their inquiries for ground source have disappeared. They're much more active in the air source market. And in a way, that's, well, first of all, it's not unexpected, as I say, we knew that was going to come. And secondly, we are working on that, and we are talking to government on a regular basis about trying to rebalance the tariff. And we actually asked our installers last week what they thought the tariff should be, but it is substantially more, because if you think, I'm going to take some very typical average figures, but if you think it's, say, £10,000 for an air source in a domestic house, and you're going to get 50% of that paid for, but you're going to spend £25,000 on a ground source, again, very ballpark figures, £6,000 is not going to cut it. And for me personally, it wouldn't cut it. So we asked our members what they thought, and it should be more like in the region of £12,500 to £15,000 incentive. Obviously, that's a very big amount of money. Yeah. Whether that will happen and whether government will listen, especially in light of the fact that people are not taking up the bus as much as they thought and hoped, remains to be seen, but it's something we're actively working on right now with government to see how we can rebalance that tariff.
Yeah, that's really interesting. And I know we're going to talk a bit more about that, but thank you, Laura. I was going to move, I guess, a similar question to from different sides of the market then, but if I can move on to Nathan a bit, from obviously your expertise with and your focus with looking at industry capability to deliver there. What is your, hearing what Laura and the panel are saying, what is your experience, Nathan, been in the sense so far of the impact of it? I know it's still in some ways is early days and we have the extension there, but in terms of where the policy is at the minute, how are you sort of seeing that in the market?
Well, it's interesting, like Laura says, there's this kind of a big difference, bus for ground source and bus for air source.
Yeah.
If you're talking about what the engineers think, there's engineers always have different viewpoints. Some see it as it's working okay for them specifically and for their customers. Others don't see that. I mean, obviously, what the bus has done is engendered sort of this wider discussion. We're obviously seeing it a lot more in the news. People like the Telegraph like to talk about it and stuff like that. So it's created, it's definitely created awareness out there in society, which is always a good thing. I suppose even negative publicity is a good thing. It's getting people talking about it, and then of course we have to get all the experts to come on and sort of mitigate and attenuate all that rubbish that some of these papers do portray. As a policy instrument, I don't think it's quite there yet at all. I think there's better ways we can sort of inspire or encourage homeowners to I mean, obviously the big thing about this stuff, I mean, it's not the technology. One of the things I always try and tell people is heating is a system. So whether it's a boiler, gas boiler system, oil boiler system, heat pump system, it's a system. So it's the heat pump system that's quite expensive for some consumers. It's not the actual equipment always. And obviously people don't have a lot of money. So they need some sort of incentive to be able to help them install this if we want them to install this. So I think there's hopefully something going to be better in the future.
Well, I guess that maybe some of that comes with understanding a little bit as well. It's a different technology in a sense. I know a lot there is, and I think some of the research we're seeing at the minute is that understanding about a different way of thinking about heat rather than a box replacing a box with a box. It's a bit more of a different approach to how houses are going to be heated there. I mean, I guess building on Dave, what you were saying, and Ed, I was going to come to yourself from Altecnic side as well as a supplier and providing solutions there. Is that sort of, as the panelist experience sort of playing out in the impact it's having on you as a business, I guess, in the type of services you are offering with regards to demand for heat pumps and how that policy is sort of working there?
Yeah, I guess so. I think as a manufacturer's perspective, it's slightly different. And when I talk about a manufacturer, we don't manufacture heat pumps. We manufacture components for OEMs, so for heat pump manufacturers. But obviously, we have components which also go into heat pump systems, and we talk about normally the secondary side or the protection side of the system. So it's a difficult one for us to sit on the outside, I think, and talk about the impact it has, because we're still quite, you know, although the heat pump world isn't new, you know, it's still relatively new to us on a grand scale. You know, it's been around for a long time. But, you know, we've certainly seen changes in attitudes and some of the products that now people are installing. And I think what's really good, again, certainly from a manufacturer perspective, is having people in the industry, like the people who sit on this panel today, who have the knowledge to be able to work alongside manufacturers and say, well, you know, these are certain components that work, or you know, this is what we see in the markets or other installations and stuff. So I think, you know, the extension can only be a good thing, because I think it's going to drive hopefully more demand for you know, for heat pumps. But I think the question that we have to ask ourselves is, why do they need to extend it? You know, there's not been the uptake. What have been those restrictions? And I know that we're going to discuss that later on in the discussion. But yeah, so from a manufacturer perspective, it's we sort of sit on the periphery of it, so we probably don't see it the same as what lots of Laura and Nathan do. But the uptake certainly isn't there. If you would compare what we put into a traditional gas boiler system compared to what products we're still into a heat pump system, there is a huge delta at the moment. You know, there is it's not even comparable in the amount of components that we supply to one to the other. So, you know, maybe the demand isn't quite there at the moment. And I know the people in this panel are working hard to try and change that. So we just need to, you know, close that delta down a little bit, I think.
Brilliant. I mean, actually, I had a question in, and I think that probably builds on some of the points we were talking about. I'll move first to Laura, if I may, on this one with the question we've got. But it is an interesting point someone's raised about the issue of fabric first approaches, which I know has been talked about. But actually, the sense of, you know, we talk and the idea of systems and thinking holistically, you know, you're putting a system in, but it needs to be efficient as well. One of the questions here is about, actually, is a strong fabric first approach, is there a risk that becomes an impediment though to getting sort of heat pump systems into buildings? And is there a balance there that needs to be struck? You know, there's this argument about should we be making sure homes are much more efficient as the main priority? I think someone here is asking, actually, is there also a balance there that we become too bogged down in one way and that heat pumps aren't being put in? Or is that, particularly from a ground source side, or is that kind of a dangerous, does that become an impediment or set that back if we're too focused on one part and not the holistic?
Yeah. So it would be that would cover ground source and air source, water source, any kind of heat pump. But there's a few things actually in there. So as an engineer, I'd always say fabric first, because if you were running a gas boiler, that's going to save you gas consumption. If you're running a heat pump, it means the heat pump can run more efficiently. So it's going to run efficiently, and it's going to take less electricity, so it's going to cost you less. So there is always a balance between how much is it going to cost you to upgrade the fabric of your building versus how much are you going to save by consuming less gas or consuming less electricity. But it's a good idea, but it's absolutely not a blocker. So the second thing is that there's a lot of stuff that goes on in the media that says you must put double glazing in, you must insulate your house to within an inch of its life, otherwise a heat pump will not work. And it's frankly absolutely untrue, and everyone on this panel will say that also. And I think that's something we've got to overcome. So if there's an impediment, it might be that people think they need to take their floors up, take their walls down, basically rebuild their entire house to have a heat pump. That is an impediment. There's plenty of older properties. As Cordina says, you know, it might be that the Victorian house have had some fabric upgrades, maybe they haven't, but it hasn't stopped them having a heat pump, because as long as it's designed correctly, it'll work. So I think that might be where the impediment is. It's still a good idea to do fabric first, but it should not be a stopper to say if you can't do fabric first, you can't have a heat pump. So yeah, that's my view. I see some hands up.
Yes, yeah, I was going to say, if I go, Cordina, and I'll come to Ed on that one, because I know the energy efficiency is today and the big point about the wider debate. So Cordina, I'll come to you for your response now.
Is that me? Sorry.
It is, yes.
Yeah, okay. No, sorry, I just wanted to build on what Laura was saying. And the question that you asked around balance is kind of an interesting way to frame it. And the way that we kind of see it at Nesta is that, you know, we need to prioritize insulation for those homes that are in fuel poverty or risk of fuel poverty, but most homes will be okay with just installing a heat pump, is I think how we see it. And also, I guess it depends on the sort of macro or lens that you're looking at the issue at. So if you're looking at cost, so like how much would cost, for example, to insulate all homes in the UK to EPCC, I think there's 250 billion pounds in total. That's the same cost it would take to install low carbon heating in all homes in the UK. So I think that when you kind of look at it at that macro level, it just really kind of pushes this point that, you know, focus on insulation on those homes that are at risk of fuel poverty, and then just go with low carbon heating solutions for the rest.
Yeah, that's great. I mean, I think that's sort of what the question was getting about there, because obviously a lot of messages are about the efficiency, and we're talking to that today. I mean, I guess Ed, if I bring you in, I know you had the response.
Yeah. It was probably more of a question for Laura as a discussion point about the fabric first approach, because obviously the updates to Part L, they talk about fabric first and stuff. But do you think there is too much focus on new build when it comes to installation? Because obviously, you know, fabric first can't be done in a building that is potentially, you know, 200 years old, because the fabric is already there. We have to adapt to what's already there. And is there a misconception that fabric first should be taking an approach on every building? When you know, I think we've said before, Laura, there's no one size fits all solution when it comes to a heat pump. So do we need to look at focuses on different types? Well, I know, you know, we've spoke before, there's data that show they work in Victorian buildings or older buildings, but is the fabric first approach, I know you say it's not a blocker, but is it a bit of a smoke screen, do you think, in where we're looking at things?
I think so, actually. I really do. I mean, you know, you've got the new build, and if you've got a new build and you're doing a major overhaul retrofit, it makes absolute sense then to get it right from the start. But if you haven't been able to do that because it's not a new build, and you look at it and you go, I can't do it, then you can't do it. That's it, you know. So it's absolutely right. No size fits all. It makes sense to do fabric first where you can, which would be new build. That's dead easy. Retrofit if you're rebuilding a house anyway. But yeah, if you can't, then it is a smoke screen, because you might end up with a slightly bigger heat pump and it will cost you slightly more to run, but it does not stop you having a heat pump in the first place. Yeah.
Nathan, I know I've put that to the panel there, but to come to yourself on that view. I mean, obviously we talk about the cost and the efficiency side there, so I'm interested in that, you know, on your view in that sense about how the arguments around efficiency and fabric first, what sort of impact is that having there?
Well, I could probably do a whole podcast on it. Fabric first, yes. So I mean, obviously insulation makes sense. It actually probably makes more mathematical sense for gas boiler systems and oil boiler systems, and I'll discuss that in a minute. I mean, I don't know who the audience are. There's going to be some very, very clever people in that already know what heat pumps are. I mean, very simply put, a heat pump is something moving heat from an evaporator to a condenser. They exist everywhere. So a vending machine keeping all them rubbish fizzy drinks cool or at a certain temperature, that's got heat pump technology. That Costa coffee machine in the service station, heat pump technology. Fridges, refrigeration, containers, that air conditioning unit that what you see up in the ceiling when you walk into your Tesco Sainsbury's, that used to be a very, very old pub, isn't just cooling you in the summer, it's heating you in the winter. No one insulated that building to put that VRV technology in. So air-to-air heat pump systems are literally everywhere. Every city, all their old offices have got some of these systems going in, heating and cooling people. So you definitely don't need to do fabric first for these things to work. Now, the thing about the mathematical thing is with a gas boiler system, you can buy a new gas boiler today, go and put it in someone's home, and it's because it's heating the system, it will run around 80% efficiency if you've done it badly, or you can get up to about 95% efficiency if you've done it well. With a heat pump system, the variation in efficiency is huge. So you can go and put a heat pump system in an extremely well insulated home, and this has been done. So let's use Energy Sprong, great company. Good thing about Energy Sprong is they actually are measuring performance. So they've got heat pump systems running in where people have spent tens of thousands to insulate these, encapsulate these homes, running with about 240% efficiency. Sounds good compared to a boiler, but it's not when it's in heat pump world. 240% efficiency means for every kilowatt that compressor is using, you're only moving 1.4 kilowatts of heat into the home. Now, you can get a good engineer, Laura and I will know, who can actually do 400% efficient systems. So for every kilowatt the compressor needs of power, you can move 3 kilowatts of heat into the home. There's this huge variance in efficiency. So just by insulating a home doesn't mean you're always going to get that efficiency. So there is a balance. I'm not saying people don't go out and do stuff, but it's not always as easy as people think. Putting loft insulation in, if you're an elderly couple with no relatives that can get up there and move all that kit out, because no one's going to insulate your loft with stuff in it. You have to move it all out. And if you're elderly and got no one to do that for you, and it is quite a chore, because I did it 5 years ago and I'm not that old, but it was a chore. It can be difficult. Cavity wall insulation historically is never performance tested. No one performance tests it, so it can be put in really badly. Trust me, I've drilled a lot of holes in a lot of walls that are supposed to have cavity wall insulation. None of that insulation looked like it was there. So mathematically, it probably makes sense to insulate more with other heat sources, coal fires, log burners, gas. With a heat pump, I'm not saying, but this mantra that says you need to insulate a building before you have a heat pump installed. Just go in and walk into your local shop, some of these old restaurants, all the cinemas. No one's walking into the cinema and seeing radiators or underfloor heat, and they're all being heated with VRF technology or VRV technology, and some of them are really old. So there is a balance. I'm not saying don't do it, but people spend thousands and thousands on double glazing, and actually it's not always been put in properly. No one will ever know. So you can get very cheap air-to-air systems. Air-to-air can go in domestic properties very, very cheaply. And then obviously, if you're doing what we call hydronic heat pump systems, which are air-to-water, as Laura will know, there's a lot more design consideration, a lot more design consideration. And if you get that right, you get the installation right, and you get the commissioning right, you've got an efficient system, whether you've been insulated or not.
Yeah, and it's an interesting one. I know a few of you have mentioned there about that and I think the last winter would have hit that home, that the efficiency argument in a way goes beyond. It's become sort of associated with heat pumps, but it's heating. There was certainly a public understanding about the importance of just cutting your overall energy use down, regardless of the type of system you're using and the source of that there. I guess to move on, I know we're looking there for some of it. I guess there's a complexity here a little bit, and I'll come to Cordina. Like all things with low carbon efficiency, it's a much more sort of complex calculation. Now we've got some notable announcements from the last year or so from quite large UK-based certainly suppliers and utility groups. We've got Octopus Energy and British Gas, who are looking to begin to offer that sort of commercial package there. Sort of more commercially focused. Is that will that help in a way and perhaps kind of make the consumer acceptance and understanding of a heat pump, or rather remove some of the responsibility to get that there? Is part of this sort of market led there in a sense, and is that an effective way to be able to offer perhaps more commercial, lower cost packages? I know some of that's seen as it can be a bit of a challenge to offer at scale, because are you looking at the sufficient needs of a property there? And I guess I might go to Cordina if it's all right there for research wise about her views on that, and I'll come through the panel about what we see about making this more commercial and whether that's the right approach to go in some senses.
Yeah, obviously the price kind of offer and bringing that upfront cost down is hugely kind of attractive, and I think we'd all agree that cost. So if you're looking at air source heat pump, around 10k. If you're looking at ground source heat pump, like Laura was saying, much more. So definitely attractive in terms of bringing that cost down. But I think one of the main challenges that we face as kind of more consumers choose this option is kind of quality of installs, and also the supply chain capacity to actually install these systems, and I think that's the point I'd like to focus on. And we did some research that we published last year looking into the capacity of the industry to install the heat pumps, and we think that there's around 3,000 trained need at least 27,000 by the 2028. So that means kind of increasing the number of installers by around 4,000 to 6,000 every year, and that's more than exists in the industry as a whole currently. So that's a pretty stark challenge, and it's quite daunting kind of thinking about the sort of changes that we need to make and the speed that we need to be making these changes at. And there's a variety of different kind of barriers and reasons why gas engineers are making that switch over to installing heat pumps, but also why we're not attracting kind of enough newcomers, so people coming through apprenticeships and colleges to kind of installing heat pumps. But yeah, I think great news, but kind of quality of installs and capacity kind of still stands as a challenge.
Brilliant. I mean, I guess I'll go to Laura as an extension about that. But I guess we talked about balance. So is that a bit the balance about we're balancing that cost with the quality there? It was to get a view, or in a sense, about making the technology more commercially appealing, commercially understandable, I guess, to the end user, and I guess installers to some degree as well, to provide that.
Yeah, I mean, I presume, I think later on we're probably going to talk about running costs, because actually if you can get your running costs down, the capital cost becomes less of an issue, and that's the big topic from our point of view. But I've written a couple of things down here. You know, it does concern me to see people offering, it's not so much ground source, actually a lot of air source, particularly, you know, British Gas and Scottish, you know, Scottish Power, Scottish and Southern. It does seem a bit of a race to the bottom. Yes, people want it to be cheaper, and yes, if we're going to get it installed, it does need to be cheaper, or cheaper as a system overall running cost as well, not just, oh well, I could get a boiler for £2,000 and I've got to buy a heat pump for £10,000, so obviously I'm going to go with the gas boiler. It does concern me, as Cordina says, about the skills gap, and actually that's probably my biggest concern. If I was going to get a heat pump now, I wouldn't go with any of the people that are just offering it now, because I'd be very concerned about how well they're going to do it. So you've got everything from heat loss calculations. I've come across people who last week were working in Aldi. This week they're doing heat loss surveys of properties in order to size heat pumps. That's very concerning. Quality of the install. So although the heat pump itself may not be that expensive, or even if it was more expensive, it's going to work. But if it's installed badly, if it hasn't been connected in properly, if it's not being controlled properly, if the owner doesn't know how to run it properly because the guy's just, or girl has just come in, stuck it in and walked away, it's not going to work full stop. So whether you're paying £2,000 for a heat pump system or £10,000 for a heat pump system, if it's installed badly and not done correctly, it's all going to fall apart. And that starts right from the heat loss calcs through to, you know, commissioning and operation. So it does worry me, but I don't have an answer to the skills gap. I do get asked this a lot, you know, what can we do? What can we do about education skills? I don't have an answer other than it's going to take a long time for us to get where we need to get.
That's good. I know I'm going to pester you guys a lot in the second panel on the skills gap, a lot more on that one anyway. But Ed, you've got your hand up there.
Yeah, I think just really on the sort of cost of things, and you know, unfortunately, I think what people tend to do is compare the cost of a gas boiler to the cost of a heat pump. But I think what you have to remember is that the demand for boilers is far greater. The production is higher. They turn them out in tens of thousands, if not millions of boilers a year. So the cost to manufacture these items is relatively low, because they can do it on such a mass scale. But while there's no demand, it's difficult for manufacturers to be able to reduce costs when the demand isn't always there. So I think as demand starts to increase, we could hopefully start to see. But you know, I think comparing a heat pump to a boiler, you know, the actual manufacturing process is not really comparable, because the economy of scale is just so much different. So,
I mean, to build on that, I know it's probably a good. There's plenty of questions left. I know we've got some of the questions here, but actually we've got a second panel coming up shortly. Actually, we're talking about skills, but I'll take some of the questions over to that. But I think we're probably actually coming up to the end of the first panel. So I was going to actually start, if I may, push for just as a final question for each panel member to consider. I think this hopefully bring in some of the points talked about, but without going over too much of the details, I guess what I was trying to get an idea from them, and it's very difficult to be succinct, I know, but in a few sentences, for what they see as the most crucial factor or change from where we are right now in 2023, to going forward to 2028 to that 600,000 heat pump target. What would they see off the top of their heads? And I appreciate these very rarely just one issue topics, but what would they need to see to get those annual installation figures as a start, or what would be the most significant change from this point we might be able to make? I guess I'll start with Nathan, if I may, and then I'll go for the rest of the panel on them.
I suppose the easiest answer that would be homeowners getting some money. I just, whether it's through policy or innovation, I just want to pick up on a question someone's put about COP, and because I think they said it after I was talking about energy. They mentioned a COP of 3 is 1 kilowatt in, 3 kilowatt out. They're right, but what that means is for 1 kilowatt of electrical power your compressor uses, you move 2 kilowatts of energy in from the air outside to give you a total of 3, because that 1 kilowatt of electrical power also ends up as heat in your home. So I just wanted to clear that, because that might have been where the confusion was coming. But yeah, to answer your question, I mean, it's either going to be policy, innovation, money is obviously the one people need, isn't it?
Yeah, it's probably one. It's a tough one. I know that kind of that becomes a bit of a dread point sometimes for government, I guess. But yes, I know. Yeah, it wouldn't be. I don't think it's probably controversial to say that money can be a big issue on that one there. And Cordina, if I can put the same question to yourself.
Yeah, I'm going to be boring and agree with Nathan. I think money, but I can expand on that a little bit. I think money, but to be more specific, I think kind of additional funding for the bus scheme, not kind of enough extending it, but we'd want to see more kind of money in there to support it. Also exploring kind of options for low cost government-backed finance, so kind of figuring out novel ways to help people pay for heat pumps. And then lastly, and perhaps my favorite, is reducing the price of electricity. So removing those environmental levies from electricity and onto gas. I think it's going to make a huge difference in terms of running costs.
And I know the government have sort of, they put a few more details that from 2024, we might start seeing that. I know originally it was some point this decade, but whether that's encouraging, it'll be interesting to see if that starts to get some action there. If I can, Ed, if I can come to you on that one, and what you?
Yeah, I think for me, and it's something that we've spoken about on previous webinars, is people's perception and attitude towards heat pumps. And I think is giving them a greater understanding of what to expect with a heat pump, because I think at the minute there's this massive comparison with, gas-fired boiler on the wall. You've got heat on demand. You can do X, Y, and Z. You can boost rooms. I think bringing people into an understanding of how they work and what to expect, as opposed to always comparing to what they used to have, would help as well. Because all you have people say is, well, it's not as good as my gas boiler, it's not as good as this, it's not as good as that. And I think setting people's expectations, but changing our habits as well. I do a lot of work in properties where I go to do surveys and look at stuff, and they've got the boilers or the heating on at 30 degrees on thermostat, they've got the window open. It's never going to work for anybody. So I think changing our habits as well is a big key, I think, to driving this forward.
Yeah, bringing the people into it. And Laura, if it's possible to get your view on that.
Yeah. Well, Cordina's already said it, and I said it earlier, but the biggest thing I think is going to be the electricity costs. So, traditionally we've always had extremely high electricity prices, extremely low gas prices. We are starting to see them coming closer together, but still, until you can run your heat pump for much less than a gas boiler to overcome the initial cost, it's going to not penetrate as much as we need. So the one thing that, we work with the Heat Pump Association and the Heat Pump Federation, and it's one of the things that we are total agreement. We are lobbying for the removal of the levies, but also a heat pump tariff. So if you have a heat pump, you get a tariff for your heat pump, which could be 9 pence a kilowatt hour. That would be a massive turning point for the industry.
It's interesting, and I guess that can be on behaviour change as well, in that sense. Then that you're kind of making a very active beyond the finance itself. You're kind of, I guess, the way people think on that one. But that's brilliant. Thank you. There's plenty more questions. I don't know. Apologies for those we haven't got in. There will, as said, be some time too. I think some of the more technical and skills-based ones we're going to come back round to there. But to thank you all for that there, I'd just like to thank you all, the panel, once again for joining us. We're going to be bringing you all back, but while we've got you here, to say thanks to Ed, Cordina, Nathan, and Laura as well. And I'm going to keep Ed, you on there, because ahead of our second and final panel, I'm delighted to say that you're going to give everyone a break from me talking for a few minutes, and we're going to hear from you, Ed. Just give us a brief discussion on some of Altecnic's work and project focuses at the minute with regards to theme of efficiency.
Absolutely. I'm just going to share my slides, so hopefully you can see these shortly.
It's looking good. You've got a screen sharing. Yeah, that looks good, Ed.
Yeah, I'll just smack some more screens. You see that okay?
Yeah, we can see that perfect.
Okay, so we just got. I feel like I'm doing a commercial break now. I feel like that's where I'm at with this bit. But I just want to sort of give everybody a little overview of Altecnic as a business, who we are, and some of the products that we do, and some of the market sectors that we serve when it comes to heat pumps. So you get a little bit of an understanding on where we are on this part of the market. So us as an organisation, we're part of the wider Clefi Group, which is still a third generation owned Italian company. We've got our head offices in North Italy by Milan. And we still have our CEO, Marco Clefi, who is his third generation. UK, we turn over about £60 million in the UK, with just over 120 employees. We've got all our ISO certification. We are currently in the middle of moving between our old building and new building. We've outgrown where we were before. So we've just taken on a much larger building where there's going to be more innovation, training centres and technologies, etc. within that, within there. We were going for just over 30 years in the UK, but Clefi as an organisation been going for longer than that. And we want to lead in the manufacturers and suppliers of hydronic solutions to the plumbing and heating industry. So some of the market sectors we serve, and this is probably where it comes into sort of fitting where we are in around heat pumps and stuff. So we have three sides of our business. That's trade, OEM, and specification. Trade, we serve our nationals, our independents, and our buying groups. So what you buy normally over the counter in a merchant. But obviously that involves some of the heat pump products that we produce as well. OEM is a big one for us when it comes to heat pump manufacturers, but also boilers. So that's where we supply individual components which go into larger installations of boilers, etc. So some of the heat pump world takes some of it could just be a piece of brass, some of it could control valves, etc. But OEM is where we supply manufacturers from their parts, but also specifications. So we talk to M&E contractors, housing associations, architect specifiers. And I think what's quite interesting from a specification point of view is where we're seeing that real change now in heat pumps. So specification generally traditionally has been very much a world of district heating for us. So we sell heat interface units into communal heating systems. And there's a big change now on a commercial scale to start looking at installing heat pumps into those. We've got a couple of ongoing projects at the moment. One, which I worked on previous with Laura, not necessarily a large commercial install, but like a large domestic, should we say. So some heat pumps feeding various properties using things like heat interface units. So that was quite interesting. But certainly some of the bigger projects, we're working on a big one up in Scotland at the moment, where they are building a new outdoor centre, and they're going to be using heat pumps to create their heat source there for their district heating. So heat pumps we're seeing more and more now coming into the commercial world, I think, trying to replace the big old gas-fired boilers. So trying to put more of a renewable heat source in there for district heating. So setting the scene really, so across Europe, currently 3 million heat pumps were sold in 2022. And that was the increase in 4% compared to the previous years. People say it's relatively new to the UK. I think in a domestic property they are, but I think as Nathan touched on before, in what he was saying, is that heat pumps or heat pump technology is in our everyday lives. What we see when it comes to vending machines, coffee machines, heating, cooling of buildings, we see a lot of that already in there. So it's not new technology. I think it's new to us, and I think we're trying to learn how we can adapt our way of life to that. There's a lot of legislation that sits around things like the Future Home Standard. Policies constantly changing. I don't know, changing is the right word, maybe moving. It's always a bit of a moving target, should we say, when the government sets a policy or a target, because 9 times out of 10, it's going to move. Things like UKCA after Brexit, that's continually the deadline that for moving. So it's difficult for everybody, I think, involved in the industry, this part of the industry, to focus on something when it's always a moving target, but we do certainly try our best. Training availability, I think training is a huge thing. There's a lot of people, people on this panel who've got a huge amount of knowledge and understanding of how heat pumps do work, how heat pumps can work in different sectors or different installations, should I say, sorry. And I think we need to lean on these people to really start to drive the industry forward. I see a lot of gas engineers now converting over to do heat pumps, which I think is a good sign. There's always been a conversation, I think we'll talk about it in the second part of the panel, where we talk about the installers that we need. We don't need to train new, we can upskill or retrain some of the people that we already have, but we are very, very short on what we need. And from product trainability, people like manufacturers like ourselves are always willing to offer training on certain products which sit within heat pump markets to get people to have a better understanding of what they are. Some of the discussion points looking at, so an overview, so components for heat pumps, and I don't necessarily mean the components that sit within the heat pumps, but some of the components that sit around heat pump installations. So once we've generated that heat, we've got that heat to use, how can we then transfer that through, whether we're on the floor, whether we're through radiators, what technologies have we got that can be used to help that and make it a more efficient system. Again, we talk about legislation and policy. It's always going to be a key topic. I think when there's any kind of round the table discussion about things like that, it's always going to be at the forefront of it, because it kind of what drives our industry and drives the market forward. So we have to be very reliant on that. Heat pump protection optimization, again, we look at componentry which sits within there. So antifreeze valves, thermostatic radiator valves, filters, etc. They all play a key part in not only protecting the system, but hopefully increasing or helping the efficiency of the system. So that's really key from a manufacturer's perspective. Certainly, designing the system. We're not system designers, but we work alongside a lot of people who do a lot of work. I mentioned the project that Laura and myself worked on previously. We sort of put 2 or 3 different heads together to try and solve some problems, and I think that's one of the really good things that I found with working with people within the heat pump industries, that they're willing to accept. There's a lot of people in all industries where they know what they know, and they're not prepared to take advice or listen to other people. Whereas I found certainly in the heat pump world, we're getting a lot of good good conversations, so we see from there. Training information, again, there's lots of out there. Nathan offers some great podcasts and webinars. We offer training as an organisation on all of our product range, not necessarily just what sits within heat pumps. So that's always key. And I think the future, we're trying to predict, and it's certainly something that we spoke about in the first part of the presentation, was what is the future. And I think we all know where we need to get to. I think we all know where we want to get to, but there's certainly some hurdles and some restrictions in place at the moment that comes around that, and I think we've touched on some of them before, whether it be cost, whether it be misinformation, misconception of how they work, the building types, the fabric first approach, all that kind of stuff. We need to start generating further conversations to talk about all those sorts of components that sit within the system, and how we can get a better, cleaner and more efficient and hopefully cheaper future for everybody involved. Because the government, they're going to take gas out of it. That's what they're saying. They're going to remove that boiler from your wall. So we've got to find an alternative source. Heat pump technology is there. It's not new, as we've said before. We've just got to put some trust and some faith, I think, into that. To help us to be able to drive forward with that part of the industry. Components for heat pumps. So heat pumps can be costly investment that need to be protected. Such careful considerations should be used when selecting components to optimise and protect each part of the system. I think that sort of goes without saying, when you are investing 10, 15, 20,000 pounds into a system, you want to make sure it works efficiently, you want to make sure it works correctly, but you also want to make sure it's protected. You don't want to come out one day and find out that something's been damaged because it hasn't got the right protection. We do it on a standard installation within a boiler with things like safety relief valves and other safety components. So it's just as important that we have the right componentry and understand what components can sit within the system. Things like antifreeze valves for frost protection, I understand, and I know that there's a lot of conversation that goes on around antifreeze valves, but certainly they're still part of it for some parts of the market. Thermostatic radiator valves, or the way that we control the heat. We've generated this heat to a certain level. We now need to move it around. We need to use it efficiently, use it in the best way we can. So things like thermostatic radiator valves or dynamically controlled radiator valves can all help. in the system. And we talk about efficiency. We want to keep that water flowing around the system. We don't want to have any dirt or air in that system which could hinder that efficiency. So fitting the right sorts of kind of dirt and air separators or filters, should we say, that are going to have a positive impact on that system. So from a manufacturer's perspective, when I talk about manufacturing, I mean for componentry, not necessarily heat pumps. We have to make sure we have the right solutions that fit within that part of the industry. And that's all from me, Neil. That was just my brief slides. So hopefully that was okay, and you could all see the slides okay.
Brilliant. Yeah, we're looking all good on that one. I think thanks. I think that sets us up is quite a good bridge between what we've been talking about earlier, and I guess going a bit more into that technical side. I think we've got plenty of questions coming through a bit on that, so hopefully be challenging you a small bit there. But as I said, I'll build on from while we've got you here, Ed, but we go to our final panel session for the day, which is going to look really and get the panel's views about the main theme we've been talking about, which is about optimizing heat pumps with regards to system design. And I guess getting the effective use of components and also, I guess, a sort of understanding of what efficiency means for heat pumps, perhaps compared to a solution such as a boiler, which is I guess, commonly understood. So if I can, now we've got Ed with us, but if I can bring back, I'd like to say we've still got Laura Bishop here of the Ground Source Heat Pump Association, and Nathan Van Gambling obviously is going to join us from BetaTalk as well. So thanks again all for joining us. I'm going to start with Ed, if I may, and then go through the panel. But I guess building on what you would say in there, Ed, about compared to our common view of heating technology, which would obviously usually be a boiler there. How do heat pump systems compare, both in terms of components, but in terms of what we look at in terms of what an efficient system is? Is it still the basics that we should know and are doing, or are we talking here about getting that understanding about what makes a system more efficient as a heat pump, and what should we be aiming for, I guess?
Yeah, I think from an efficiency wise, you're probably going to get a more detailed answer off Laura and Nathan on that, because they sort of live and breathe in that world. So I won't comment too much on that, and I won't, I wouldn't want to put any misconception out there. I'd rather those guys, put some real detail around it. But I think componentry wise, they're not too dissimilar now. What we're trying to achieve is heat. We're trying to achieve heat in a room or heat in a building that's done efficiently, as cost effectively as we can, and that's at no real detriment to the systems or to the end user or to the homeowner. So in that respect, yes, it can be generated at a lower heat potentially, but it's just about using everything that we generate. We're very wasteful, I think, in the way we generate heat. And I've said this before, in one of the previous conversations that we said, the amount of times I go to buildings, they've got heating on, they've got windows open or whatever it may be. It's just not an efficient way of doing it. So componentry wise, you still need to control your heat. You still need to isolate it, should need to. You still need to have, dirt and air separation in there. Some people may want antifreeze valves, some people may not. I know that's a hot topic, certainly across social media at the moment. So not massively dissimilar. Yes, you're going to potentially using bigger radiators, etc. But componentry wise, I don't think there's a huge amount of difference. But I think from the efficiency side of it, is probably best answered by someone like Laura or Nathan, who can probably put a little bit more expertise around it than what I can.
Oh, that's brilliant. That's teased me up quite nicely, because I will put. I'll go to Laura and then I'll go to Nathan, if I may, about that question. And I guess building on, also asking in a sense as a panel that I guess on the sense of this understanding and the differences there, but what are the critical issues and considerations when really to get a heat pump right? But yeah, that sort of design and installation. And Laura, obviously from your experience with the Ground Source, so I was trying to get your view on what you'd see there from that.
Yeah, I think the because the heat pump itself, it's the same technology inside the box. So whether you're doing air source, whether you're doing ground source, a lot of the fundamental calculations around that and understandings are the same. The key thing for efficiency is to minimize the lift. So to minimize the amount of electricity you need to consume to get from the free energy, which is your air or your water or your ground, to what you're actually going to use inside the house or the building. So if you're going in the middle of winter from air temperature of 0 and you're trying to get 70 degrees into your house, that is going to cost you a fortune. So COP will be through the floor. But if you can get, say, 10 degrees out of the ground and you're only delivering 30 degrees into the building, because that's all it needs to heat itself properly, then your COP will be really, really excellent. We can't always have an influence, or we can't influence the air temperature. So that's one thing about air source versus ground source. I don't want to get into that argument, but air source, you are very much at the whim of the weather. So if you've got a very cold snap and it lasts for 2 weeks, it is what it is, but there's nothing you could do. But if you have therefore sized your radiators or your air handling units or whatever it is to be able to operate at a lower flow temperature, you're going to benefit from a much higher COP and therefore lower running costs than if you're trying to put 70 degrees in. We're in a good position now, though, in terms of retrofit, because we are seeing the different refrigerants come onto the market, like propane, CO2. They can go to much higher temperatures. So some of the buildings I work on, they're big retrofit installations, and we are, they're usually working on 80-70 or 70-50 or something like that. We're looking to get their temperatures down to 60. And using propane just gives us that little bit of extra push during the cold weather to make sure that the building is still thermally comfortable during that time, but the COP will obviously be affected. So it's important from the outset to understand what temperatures do you really need, what can you influence. If you're going to have air source, just be aware that when it's cold outside, it's going to cost you more money. There's nothing you can do about that unless you've got your house running at 30, maybe 40 degrees C. Which you can do, but you might end up with whacking great radiators, or you may need to then put underfloor heating everywhere, which in a retrofit is not always possible. So that's the key thing. It's the lift between the outside and the inside and minimizing that.
Brilliant. Sounds simple like that. I know how complex these things can be, but Nathan, if I can come to you in that sense about when we're talking about this sort of the key technical considerations here and kind of getting that understanding of efficiency and a good system there.
Yeah, Laura's right. I mean, physics hasn't changed since people like Sadi Khan was sort of like looking into. Well, he was the founding father of thermodynamics. It's, I suppose the sentence that describes efficiency with a heat pump is narrow. The more you can narrow the delta T between source and sink temperatures, the more efficient the heat pump. So what does that mean? Well, our source is, if it's an air source, that's where you're getting the energy from. If it's ground source, that's where you're getting the energy from. That's your source. So like Laura says, the source temperature in a ground source is usually constant. In an air source heat pump, it's changing. It could be -3 in the winter. That's very rare, but averages around about 7 degrees. That's your source temp. Your sink temperature is where, in a hydronic system, in an air to water system, is basically the temperature, the mean water temperature in your radiators or underfloor heating. So if you can get them two closer together, the more efficient your heat pump system. So what does that mean? Well, it means if I can heat my home when it is -3 outside with 35 degree water in my radiator, that 35 degrees is closer to -3 than if I had to have 45 degree waters in my radiator. So I've narrowed that delta T. Delta T means the difference. Now, I just want to pick up on a quick point. There's a lot of people out there that think our homes need 70 degree, 80 degree water in our rads. And it might surprise a lot of people. Our homes never needed that temperature of water in our radiators. When boilers first become, and I get described as a great engineer, I'm not a great engineer. I don't like it. There's a lot of good engineers out there, way, way better than me. My advantage was I grew up with my granddad, and he was one of Europe's leading fossil fuel combustion engineers back when boilers started. So he brought oil boiler technology to this country from Sweden. He was half Dutch. That's where I get my name from. And the Netherlands is where the first condensing boiler came to market in 1981. And that's very important because it was the boiler that needed the hot temperatures. When you burn a fossil fuel is a hydrocarbon, so you get water vapor. Now, if that water vapor condenses on the heat exchange of a boiler, it rots the boiler. So before we had condensing boilers, we needed these very high temperatures going around the rads. And your rads ideally don't need a hot temperature all the time. And the temperature going to a radiator should constantly change depending on what the weather is outside. So if it's cold outside, heat is going to move through your fabric quicker. That's the second law of thermodynamics. If it's milder outside, the heat leaving through your fabric is going to be slowing down. So what we want to do is push heat into our home at different speeds. And we do that with different temperatures in the rad systems. We've been able to do that for a long time. And unfortunately, most of the boilers going in don't have weather compensations or load compensation systems. They're going in at fixed flow rates with an on-off thermostat. It's pretty stupid, pretty dumb way of doing things. You can do that, as Laura knows, you can do that in the heat pump world, which is silly as well. But you want to have these these temperatures varying to the rads. So it was never the home that needed the hot radiators. It was the boiler. And obviously when condensing boiler technology was invented, we could now have lower temperatures coming back to the rads. So you'll find, and back when the first heating systems, and I'm going to show you, so I don't know if you can see this, but this is the old Mears calculator that we used to use to size pipework and radiators. They were single panel radiators. So a single panel radiator, as long as they were clean, I mean, don't get me wrong, they did corrode and they clog up, but a single panel radiator was heating homes in the 60s, 50s, 70s. When it was, they were designed to work around, at the average in the UK was -3. So we don't usually have single panel radiators now. A lot of people have double panels. So you'll find that, we can get really low temps, and a very, very well designed system. You've got people designing systems now that only need 35-degree water in their rads when it is -3 outside. You need this. You need to increase the surface area of your emitter. This is why underfloor heating is good. But you've got a lot of good engineers now. They'll do that to 100 mil centers. So rather than 200 millimeter centers, they're sort of narrowing the centers because you're getting more surface area under your floor. The more emitter surface area, the lower you can drop that temperature. And that's where, insulation of fabric first is relatively important, but, getting that temperature dropped in your mean water temperature is the key for energy efficiency, because you've got this huge variance with a heat pump. You haven't got it with a boiler. You can be 80% or 95%. With a heat pump, you can be 200, 550%. Getting that temperature as low as possible is really key to efficiency.
I mean, that's interesting. We got a question from the panel to build on that, and it's a little bit, I guess, about the concept of public understanding here about this. And we use the term low temperature heating often, about trying to get this different way of thinking. How important is it that there's a public understanding of what low temperature heating actually means in terms of what we've been talking about there, or is this more about the skills in the industry side? Are we overcomplicating that there a little bit, or how do we talk about behavior attitudes, but do we need to change understanding, perhaps public side, I guess, certainly from an installer side, but is that important to the debate, or does that risk, I'll start with you, Nathan, do you think, but to kind of complicating what we're trying to do with getting an understanding from industry?
Well, it obviously helps to have educated consumers, but consumers are a heterogeneous cohort, and some have different levels of understanding. So, I mean, in an ideal world, a consumer just goes into their home and it's nice and warm. It's what they want. They don't really need to tweak things, touch things. And a good engineer can put heat pump systems in where they don't really have to touch all winter. They just do what they need to do. If you ask me, education needs a bit of education. I mean, the boiler industry, rightly or wrongly, became so big in this country, became the biggest in the world up until 2016. A lot of the science of heating's got lost. If I ask most technical directors of manufacturers what is a watt, they wouldn't tell me it's a joule per second. They've lost the sort of knowledge that heat is moving at different speeds. Unlike light, what we get from the sun, it doesn't have a constant speed. Heat moves at different speeds, and we really need to understand that to sort of do these efficient systems. There is an education piece for consumers that probably centers more around knowing who is a good installer. That poor old consumer just doesn't know who good installers are. I'm very well known for saying we teach people to be qualified rather than teaching them to be competent. There's a massive difference. Massive. I don't care how many qualifications. So I'm really qualified, but I'm no better than a lot of people out there. Qualifications aren't the be all and end all, and they don't always necessarily mean competence. Now, that's a big problem for social housing, for local authorities, because they don't know how to use on their frameworks and DPSs. And it's also a massive problem for consumers. Who do they use? That's a big problem.
Laura, I guess I'll come to you that, on this idea there of awareness there, in a sense. I mean, is that fair to say? I mean, I guess part of this is getting public on board, but building on, I guess, what Nathan was saying there about, and we've talked a bit earlier about sort of consumer confidence and consumer acceptance of the technology there. Where does that start to come from, in some sense, as we say, and building on, I guess, what we were just discussing with Nathan there in that sense?
I mean, what Nathan said there, what does the consumer want? They want to go into their home and they want it to feel warm. And when they turn the tap on, they want to have hot water. That's it, really. And if you want to have a gas boiler fitted, the last time we had a gas boiler fitted, I didn't do a load of research. I called the plumber who came out. He looked at my old boiler. He said, oh, it's 26 kilowatt. Right, you can have a new 26 kilowatt. Came in, take the old one out, put the new one in, job done. And I can turn it on and, you know, I had heating and hot water. That's where we need to get to, I think, with the heat pump industry. We don't need people to go around and do all their research and go, oh, should I have a Mitsubishi or a Valent or an EB or whatever else? And you know, do I need to replace all my underfloor? They shouldn't have to think about that, unfortunately. Well, they shouldn't, basically. They shouldn't have to think about that. What they should be able to do is, as Nathan says, is to know where to go to find a good installer that isn't just going to go, oh, you've got a 26 kilowatt boiler, therefore you need a 26 kilowatt air source heat pump and plug it into the existing pipework and hope everything's okay and forget that there actually needs to be a water cylinder on there as well. That's where we need to be at. So I think that there has to be confidence in consumers that they're not reading all these bad news stories all the time that tells them that they can't have a heat pump, it won't work for them and it'll all be terrible. We need to stop that. We need to have more good news stories of where heat pumps are working, which is why the Nesta report was so good. And there are actually loads of good news stories out there, but they tend to be trampled on by the bad news stories because, I don't know, maybe people like bad news more than good news, I don't know. But they need then, if they think, right, I'm going to have a heat pump, it's crunch time, my gas boiler's broken, that's when they make the decision. Where do I go to find somebody who is going to confidently give me the right solution for my house? And that's where we need to work on the gap between what the consumer needs and what we as industry can provide and where they need to go for that.
Brilliant. I mean, I guess that leads me nicely to bringing on, wanted to talk about skills, and obviously touched, I think, on, we've started to move into the idea of capability there. So we're trying to get from, and I'll go across the panel about the training picture at present, for getting installer and engineer capabilities in place to be able to do this. And where are we at in terms of what might we need to do to adapt how engineers, installers, and I guess the supply chain as a whole are able to put that proposition in and make sure that, as you were saying, Laura, that the public are getting heat. You know, they're getting low carbon heat, but they're getting their heat needs and that heat needs met there. And is it right to say, is it a case at the minute that it's a skills gap or a skills shortfall with regards to low carbon heating, or what are the challenges from where we are at the minute? Is it just that it's still, you know, it's the market development, or is there something missing from that picture to make sure that people have that understanding and can be delivering low carbon heat? I will go with
so yeah, there's definitely a shortage, and you know, there's a fundamental reason about this. You know, the fact that the construction and engineering industries and building services industries particularly have been going down and down. You know, whether you want a bricklayer, a plumber, an electrician, a low carbon heat pump fitter, designer, whatever, you're going to struggle now. And it's because, you know, as far as I'm concerned, the trades have been downgraded. Everybody needs to be going to university, not going on the trades, not enough apprenticeships, and now we're feeling the results of that. So again, it's going to take a while to come around again where we've got enough people. So, you know, there's a I mean, I took over as chair in two and a half years ago, and I've been working in heat pumps for the last 13 years or whatever. I think only in the last 2 years, things have really started to step up a gear, like substantially, noticeably. So, you know, we've got the low carbon apprenticeship hopefully being launched back in colleges in September, which will not have students fitting toilets. It will have them understanding how ground source, air source, solar thermal and other systems work, and actually getting them installing them 2-year apprenticeship. We have got the manufacturers stepping up and offering their own upskilling courses. You only learn obviously their kit, so you might only be learning how to fit a particular heat pump rather than understanding, as Nathan said earlier, you know, it's about not just passing an exam, it's about getting that understanding in your head. It's about, you know, why is a pipe sized like that? Why is that radiator sized like that? How do I do the calculations to work that out? So I'm not sure that whether the 2-day course will do that. It remains to be seen, but there's certainly in the last couple of years there's been a big push to you know, educate and to train new people. And I think if the government give us the steer and they stop messing about and going, oh, well, it could be hydrogen, it could be heat pumps, it could be this, it could be that. While that's happening, people are still a bit unsure as to where they're going to start training people up. But if they gave us a proper steer and said, this is where we're going to go, then maybe people would be more inclined to invest the time and the money to upskill or to put themselves onto training courses, or for companies to put their staff onto training courses to learn.
Brilliant. Thanks. Well, that's great. Nathan, to yourself, building on that idea there of the training.
The skills discourse is a very big topic. I mean, one of the things with skills is, or one of the problems is, the training industry is a business model in its own right, and it's a very lucrative model. So that sometimes steers the direction of it, not always in probably the best possible direction. Apprenticeships been around a long time. You know, the Middle Ages, they changed in Elizabethan times, they changed again in around 1812. Now, the thing is, with apprenticeships, they're great if the apprentice is learning from someone good. I've taught a lot of apprentices. I've been a college lecturer. I taught in prisons as well. And one of the problems with apprenticeships is if that apprentice is with someone with kind of a low skill, or someone that's not keeping up with best practice, that low skill is perpetuated. So there is sometimes a problem with apprenticeships. They're not always the be all and end all. I mean, obviously you go back in time, there was never a middleman of like a college or anything like that. It was the apprentice learned from the master, and they were a master. You had to be a master. Nowadays, anyone can start up a plumbing company and take on an apprentice the next day and enroll them into college. Now, I don't think the renewables apprenticeship is going to work exactly like that, but we need to be very mindful of that apprenticeships, if they're going to work, the apprentice needs to be with someone good. One of the big things with our industry is it changed in sort of the early 80s, it changed to a sole trader industry. We were an employed industry, so people talk about, we went from town gas to natural gas. One of the reasons that was so easy is because everyone worked for regional gas boards. So, you had this hierarchy of learning going on, from your foremans, your charge hands, and that was filtering down. We're now a massive, massive sole trader industry. Probably got more sole traders and self-employed people than per person than compared to Europe. So getting them to individually train is quite hard. But there has to be sort of this honest thing as well. It's not always about courses. If anyone wants to learn anything, where they want to learn how to play piano, guitar, be a footballer, the ownership of learning is on that person to learn. So, if you want to be a guitarist, you practice. It's not just about the course you go on. If you want to be a footballer, it's not just about your summer boot camps you go on. It's about practice. And that's the same with engineering. There's plenty of resources out there. Altecnic got good resources. If you really want to learn some stuff, you don't actually have to go on a course. You can learn. We live in a world of Google and YouTube. I'm not saying all of it's right, but if you get a little group of people and you have a little discussion, well, do you think that's right? Do you think that's right? So if you want to learn stuff in this world, you can learn it. And I think there's too many people that think learning is all about being spoon-fed. I'm going to go on a course and it's automatically going to go in my head. Some of the greatest engineers out there haven't got qualifications. They just got off their arse and learned stuff and engaged with other people that wanted to learn. And I think that's an important message we've got to get across to industry. You want to be good in this industry. Engage in it as much as possible and activate yourself as an autonomous learner, and get involved in peer-to-peer learning. The whole reason I started up BetaTalk was to activate people as autonomous learners and to activate people as learning resources from one another. We can learn so much stuff from one another. Like Laura said, when you go on a 2-day course, you'll walk out of that course, you probably won't even see a heat pump for 2 years. You're going to forget what everything anyone said, like a lecturer like me said anyway. So I think, we need the big message around learning is, it's mainly on you. The ownership of learning is mainly on the person who wants to learn stuff.
I guess that comes to pressures. You've got CPD, which, we cover quite a lot, and we talk about as well, about having that, the incentives or the drive to go on there. I know, Laura, sorry, you had your hand up there, so I was going to move back to yourself.
Yeah, I love to listen to Nathan actually saying about that, because he's absolutely spot on. Just when he started though, saying about, who are you going to learn from? And we do a lot of work with colleges, so not in terms of training, but in terms of putting heat pumps into colleges. And sometimes I've got caught by the plumbing lecturer, let's say, and he's downstairs teaching a bunch of students, and they're really worried because they don't know how to teach this stuff, and they're going to be expected to take a group of kids, or not kids, any student, and move them from being not knowing anything to being fully conversant with all these technologies, and they themselves don't know, and they're saying, some of them, that they're only 1 week ahead of the students at any one time. So that's something that, again, I don't have the answers to, but it's something we do have to be aware of. But then the other thing, the learning thing, and I don't know whether in this day and age people are so used to having the instant, you know, oh, I need this, right, I'm going to have it right now. Do we still have that thirst for learning? Do we still have that thing inside us that says, I need to learn to be good at what I do? And sometimes I do wonder whether we have that, and people just expect to sit in front of a training course for 2 days or a year or however long it is, and just say, right, I've done that, move into the job, and actually they've not learned anything because they've not took it upon themselves to get learned, you know. So yeah, I don't, that's a bit of a negative thing to say, but that is what I see, especially when yeah, that is something that I do see quite a lot.
One of the biggest problems with learning, it's not just engineers, you know, this is a wide discourse. We've got people that have now got titles like climate change officer and sustainability officer in social housing groups and local authority. And they've been in these jobs now for like 5, 6, 7 years. The lack of knowledge with some of these, but not all of them, the lack of knowledge is astounding. I'm fortunate enough I get to meet some of these people. They're lovely people. But part of me wants to say, you know, get off your email and Zoom calls and team meetings and read a book. Read a book. Engage with some of the people that talk about heat pumps all the time. You know, don't just keep disseminating the same message. Oh, heat pumps don't work because we got 1960s building stock. You're in an office that's being heated with VRF heat pump technology, and it's a lot older than 1960s. And, you know, learn, and that's not all of them, by the way, because I do meet people in local authorities that are fantastic, but, you know, they are the minority. And if you've got a title like sustainability officer or climate change manager, do some learning. The ownership's on you.
Yeah, absolutely. The times when I've been in meetings with people and they said, I don't want a heat pump, but they have quite obviously got a VRF system in that's heating the very room that we're sitting in, but they don't want a heat pump. And it's been in there since the building was built.
Doesn't it, in that sense? I mean, it's interesting to move it on, and I think it's probably worth raising because it's a term I think certainly our panel will know, but we've got a few questions here about the MCS certification, which has been, obviously, it's a big part of the building upgrade scheme there. And some people asking about that, and actually, is there more in-depth training, or, you know, we talk about this engagement and then the avenues for learning, but in terms of I guess it's the old argument we always have on both HMV News and RAC about the medium, the basic requirements we're asking, and I know MCS has sort of seen that there. There's a few questions I think from the audience I'd like to put to the panel a little bit about where we stand with the basic requirements and whether they're ambitious enough. And also on a slightly technical one to put you, or someone has asked what they consider the lowest SCOP in terms of MCS to be achieved when designing a heat pump system there. So I think those questions probably tie into our basic understanding or the requirements we're asking of heat pumps and how they should perform. I'll start as I've got you there, Laura, in your view, but on that MCS side, I can ask, you know, how is that being seen, and, you know, is that the wrong thing to look at? I know it's sort of become a bit of a focal point for people that it can be a barrier or not to getting people trained and installing to certain standards.
Yeah, I mean, I got my own views on MCS, but we definitely need a body that regulates what's going on. You can't have anybody, as Nathan has said, starting up a plumbing company and going and putting heat pumps in, because the likelihood is they will fail unless they have taken it upon themselves to go and get themselves trained, and in which case they might actually be better than some of the accredited people out there. So you need a body, and at the moment it's MCS. And MCS, again, has come on in the last couple of years, leaps and bounds in terms of what they're doing, how they're engaging. So it's loads better. As an engineer, some of the stuff they put out is obviously has to be quite dumbed down, and there's nothing we can do about that, because not everybody has been doing it for 20 years, and we have to make sure that there are people who are going to get trained and do it correctly as far as possible. And MCS are going to like the gatekeeper for that. I think, you know, discussions are ongoing, things are changing all the time. We've got an MCS working group that's going on, but all I can say is that we need a body to regulate. We can't just have anybody doing anything, whether you like it or not. But what I would say actually is, if you are fitting heat pumps, I would get involved with your trade body, whether you're part of the Heat Pump Association with us or Heat Pump Federation. We all talk anyway, because we are actively working with MCS to make sure things are fit for purpose. So if you have got issues and you're part of a trade body, then raise those things with us, because we can then raise them with MCS during our regular working groups.
I guess that comes to the Dave was saying about engagement as well, and being and having a voice there. Nathan, if I come to building on what Laura was talking about there with MCS and sort of standards, and I guess that idea of who's watching and holding industry to account in that sense of standards.
Yeah, I mean, like Laura will know, I mean, MCS are changing all the time. They are. I mean, I've got Ian Rippin coming on a live podcast at a show, at the installer show soon, and to announce some big changes. I mean, they get a lot of stick. Sometimes they deserve a little bit of stick. I've held my hands up. I've given them a bit of stick in the past, but you know, I think that they are trying to move it in the right direction. Very important point there from Laura. You know, if you are in doing ground source stuff, get involved with the Ground Source Heat Pump Association, the same with the other associations, you know, because these groups are there to sort of help each other. You know, we can learn a lot from each other within these groups. I mean, yeah, you definitely need, you know, when it comes to public funding, I mean, there is this argument, does everyone that installs a heat pump need to be MCS registered? Now, that's a very important, if let's say my dad decides to have a heat pump, I want to be able to go and put it in without having to get all the paperwork to become MCS. I can put one in, fine. Why would I have to go and spend all that expenditure to just be to have it as a certified install if he was not drawing on public tax funders' money, which is like a grant work? If there's public money involved, taxpayers' money involved, yes, you need someone to really regulate that. Arguably, I mean, whether 2009, I think MCS became around. So I mean, I suppose it's still in its infancy in a way. So, you know, they're still learning. So, yeah, it's unfair to put all the blame on MCS. They do take a lot of blame. I mean, like I say, they it's not always been right. And there's some things that are changing, and they are going to be changing quite a bit, I think, in the future. But you definitely need somebody. What we might see in the future is some entity try and do what they're doing, because I think the law actually says MCS or other. So I think we might see other entities try to become the other. I don't know how that'll work, or if it'll work, or if that's going to happen. I sort of do hear rumors it might. But yeah, you definitely need a regulatory body when we're talking about public money paying for installs, without a doubt.
Laura, I know your hand was up there, so I'll.
Yeah, and that just something that came to me then. Obviously, MCS only applies if you're 45 kilowatts or below. So there's a whole host of projects that can be going ahead where you don't have to be MCS. And actually, if those sorts of projects go wrong, it can be massive amounts of money that goes wrong. So we have got this, I don't know, I find it a bit strange. We regulate the small half of the market. Okay, there's going to be lots and lots and lots of them, but they're small. But if you're going to do a 50 kilowatt or 60 kilowatt heat pump up, which actually isn't that much different from a 45 kilowatt heat pump, no one is regulating you. You can go and do whatever you like. So if people don't like MCS, maybe they could do bigger systems. I don't know.
Coming to, I'll bring Ed in a little bit of this, obviously from Altecnic side there, but I guess the responsibilities and role from your side with regards to training and certification now. I mean, how is that changed, if at all, you know, in terms of, have you seen a change in that sense, or have you seen a shift in demand perhaps from what customers are expecting from?
Yeah, I mean, I certainly think from a heat pump perspective, you know, I do a lot of work. You know, we all spend different times on social media and stuff, and there is a lot of active change now. There are people who who I know who were very good gas engineers who have actively taken it upon themselves now to become MCS accredited and do the course. Again, I think like Laura said, there's good, there's bad, there's indifferent reviews that come back from MCS, but there is an active change, I think, and I think people who have got that drive and that want, like Nathan said, to best themselves, they can see where the industry is going. It may not be there yet, but they can certainly foresee that there's going to be there is a skills gap at the moment. Is it a skills gap? Is it a lab gap? I don't know, but there is certainly a huge gap in where we are. From a manufacturer's perspective, we can offer all the training that we can on the componentry side of things to understand the work, because sometimes, a heat pump is the biggest cost, the biggest expense that goes into the installation, but there are certain components in there that you also have to understand how they work: a filter, an antifreeze valve, a dynamic controlled radiator valve, whatever it may be. So I think the more that people with the knowledge, from a manufacturer perspective, but people like Nathan, like Laura, and some other active people in the industry that can share their knowledge, it's only going to make it a better place. Because, at the moment, I'm not going to say it's a Wild West, because I don't think that's the right terminology to use, but Laura said there has to be some kind of governing body that controls it. We see it very much in the world of heat networks, which is where I spend a lot of my time. There's not necessarily much governance over it at the moment. It's coming, and I think with governments can come out accountability, because I think someone can charge a homeowner £20,000 for an install. All of a sudden their bills go up 2 or 3-fold. Who's accountable for that? So I think there's got to be some kind of accountability as well to make it a smoother transition into the technologies moving forward.
Brilliant. I mean, I'll come back around again, because a question we got from the audience about taking the example of commercial projects where someone's putting out, it's not unusual that you'd have a commissioning engineer there. They were saying, in a sense, about obviously with home defects, and also that we've got to get the wider public buy-in the sense. So I think someone was asking about, in taking that model, is that something that is needed to encourage perhaps quality control or to bring that along? And is there area for, I guess, manufacturers, validation services to that degree? Is that something they could do, in a sense? So I guess it's kind of looking at the models that we taken from a commissioning engineer side. Is that something realistically, when we're already talking about getting the skills in place that can help industry, or perhaps give confidence on installers and manufacturers that the equipment is being in place and doing what it needs to do in that sense? Yeah,
I think from a manufacturer's perspective, we said this on the call, before we opened up to right, we don't spend millions of pounds on development for fun. We do because we want to put the good products out there. We want to put the right things out there. We can validate that by offering strong warranties on products, etc. But back to I did see that question. I thought that's a really good question, because my world is commercial. I come from a commercial background where you'd have a consultant would design a system, a contractor would install the system, and a separate person would come out and install the system, would commission the system. Sorry. You don't always necessarily get that, I think, in this world, because I guess you rely on things, and Laura and Nathan may correct, but things like MCS should give the people the qualification to go out and say the system's been commissioned or set up as it should be, or as per the manufacturer's instruction, and to get the most efficiency from it. But I think that there does need to be that complete circle, because at the minute it feels like we're almost like a horseshoe. There's a missing gap, and I think we need to have that full circle somewhere of design, install, and commission and sign off. That's not disruptive to the customer at a higher cost either.
Brilliant. Nathan, to come to yourself on that then?
Yeah, well, as Laura will know, obviously Laura sort of works at a much larger scale. Commissioning is such an important integral part. So I mean, you could break it down into 3 things with a heat pump system, whether you're doing small domestic or very large commercial. It's design, install, and then commissioning. So you want people that are good at this. And obviously, before we were this sole trade industry, we had all your local authorities, all your councils, or your sort of regional gas boards would have designers, and the fitters, they weren't called installers and they were called fitters. They would put stuff into that design, and then you'd have sort of the cleverer bods come along and sort of commission it and make sure everything was working all right. And obviously, in a self-employed environment, in a domestic setting, it's usually the same person doing all 3 of them things. Obviously, with the sort of the MCS accreditation scheme, we sort of have an auditing process. So your certification bodies like Optimising, APHC, NAPIT, NICE will do auditing work to see that your sort of commissioning work is sort of up to standards, I suppose. Arguably, that's sometimes overlooked. You know, arguably commissioning isn't going on as good as it could be. I mean, someone asked a question, Neil. I just want to pick up. They said, Nathan, what is the definition of a what then? I might not have given it. I mean, I talk a lot. I talk very quickly. I'm dyslexic, so sometimes I talk fast on what I think. So what is a what? Well, a watt is 1 joule per second, and it's actually good to think of heat as speed. So I mean, if the average home in the UK, and it has been the average for a long time, is 8 kilowatts. So the home needs 8 kilowatts of power when it's -3 outside. That's what we tend to design systems to across the country, -3 outside. It'll need 8 kilowatts. So what does that mean? It needs 8,000 joules of heat being pushed into the home per second. And that's because the home is losing through the fabric 8,000 joules of heat per second. So you match that up, because if your home does need 8 kilowatts when it's -3, it will only need 5.5 kilowatts when it's 0. So it'll only need 5,500 joules of heat pushed in every second into the home via the rads underfloor, because that's what the home's now losing. If it was 10 degrees outside, you know, a nice and mild day in winter, your home's only going to need 3.7 kilowatts. So your rads only need to push out 3,700 joules of heat per second, because your home's losing 3,700 joules per second. That's why temperature to our radiators should always change, whether you've got a gas boiler or boiler system. Or boilers, it was hard because you never had modulation, but you have now EOGB demodulation now with their oil boilers. So yeah, I just wanted to clear up that question. What is a watt? It's a joule per second. And it helps actually to think of heat in speed and moving at different speeds. It really does. And that's why we changed the temperature of water. Going back to commissioning, that's part of the commissioning process, you know, seeing if your design temps are being met. Is your control strategy modulating that temperature? Sometimes heat pump systems are getting put in with fixed flow temperatures. Some companies do that on purpose just so they don't get callbacks because the home's not heating up properly. But of course, the electric bill is going to be a lot higher than what it needs to be.
Brilliant. I mean, I guess that's Rollers. I mean, there are so many more, and I apologise I can't get all of the technical questions over to the panel there. But I'm going to, as I bring it to rounding up the session, I guess I was going to ask the classic example, but if there was one priority coming out of this, that, again, in terms of the training, skills, certification of where we are now, and what we can be, what we may well be, or what we should be by 2028 and perhaps beforehand. What do we need in terms of getting the ability and the skills in place, but that understanding there as well, to make sure that we've got the best, most efficient systems, we've got the components sort of operating. I will go, if it's not too picking, I'll perhaps start with Laura and then go to Nathan, and then I'll finish off with you then as well, if that's I'm asking you to be succinct on very complex things, I know.
Yes, I actually struggle sometimes to think what the key thing is, but one thing that's come out of this is the commissioning engineer. I know it will add on cost, but if you had somebody who went afterwards and just like an independent check, that could be quite useful. It's not going to help us skill up, but it could help offset the effects of poor installs, which then might increase the quality of the installs to start with. But it is complex, and I don't have the answers. As an industry, I think we just need to keep talking and keep working together to try and push this along.
But in a sense, I guess that's what you're saying, Laura. That's interesting about giving the backup there, I guess, to make sure that once you've got a commissioning side to look at, identify or perhaps sort of fine tune then as well, so that that identifies sort of areas where installations and can be better run as well. But Nathan, if I can come to you in that sense with the same question.
Yeah, it's a really, really good point by Laura. This whole thing, commissioning process, this whole thing of guaranteeing quality. I mean, it's been tried before. Obviously, the Green Homes Grant obviously brought in Trustmark. I mean, nice people, but they probably wouldn't know what a heat pump was if it fell on their head. So, these schemes don't tend to work. If you want people to actually understand this stuff, you need proper engineers that understand it. I think totally sort of an abstract thing is getting to society to value heating engineers. we've lost all value of heating engineers. You know, people are prepared to pay their solicitor a certain amount of money, and even more if it's a barrister to speak on the phone. But getting knowledge from you, and don't get me wrong, there's some rubbish ones out there, we know, but you know, if you're elderly, you're kept alive by your heating system. You know, my dad retired at 76. He had people old enough to be his parents. If they went without heating, they died. And it's a very valuable trade, and society has lost touch with that. You know, no one really cares about the heat system until it breaks down. You know, we're not particularly a valued trade anymore. And I think, you know, how that happens, I don't know. It's quite abstract, but I think we need definitely these papers making us out to look like all rogues doesn't help. But, you know, there's some really good engineers, world leading engineers out there. Britain has always had world leading engineers. You know, I'm not particularly patriotic in every other sort of sector, but when it comes to engineering, we've had some of the best ever. And we need to value them because they will help. It's going to be them that helps decarbonize heating, not other people. It'll be the engineers.
Brilliant. And Ed, if it's I know finish up you there, but
no, I think you know, echoing what the guys have said, you know, there are some great engineers out there, and I think we've got to stop listening to negativity. I know we had, I'm not going to open up the can of worms now, but the debate about electric cars previously, you know, there's a lot of negativity, and sometimes it's who shouts loudest gets the most attention. But, you know, there's people only talk about the negatives in this country. We're very good at doing that. But there are, as we saw from the report before from Nesta, there are some huge, you know, good stories that have come from this, some real good, you know, live data that's come and say that heat pumps do work. They are, you know, they're not a one size solution fits all. We know that, but, you know, embrace the change, you know, see what's coming, and listen to the people in the know, people like Nathan, Laura, and other people who have really invested a lot of time and a lot of effort into understanding these systems and getting their knowledge up there to help everybody else.
Brilliant, thank you guys. So I know that there's plenty. I apologise that again could get all questions there. I think there's quite a few more specifics, and certainly we'd be able to push those onto the panel there. But I appreciate they've gone a little over time, so I really do appreciate the patience of everyone. But thank you for a great discussion on that one there. So thanks to all the panels today, but specifically our last panel with Ed, with Nathan there, and with Laura as well. And thank you all for the time. It's been really great on that one. And thank you to joining us on for the questions. Apologies, we couldn't get to all of them today, but we'll certainly be following up on with ourselves and with Altecnic on plenty of coverage on this as well. So for today, thank you for joining us, and I just wish you all have a great afternoon, and hope to see you again for another H&V News live webinar. Thank you for your time.
Thanks, Neil. Thanks all.
Thank you. Bye.